and she is a very good producer. She has been working on her audio mixing skills, and I'm sure in time she will be a valuable addition to our team. See you in the next episode.
Hello, this is Dr. Lawrence W. Moore, and welcome to Learning Synthesis with Pure Data, Series 2, Lesson 3. In this episode, we're going to look at the VCF module in LWM Rack. This is a combined low-pass and bandpass filter module that has its own built-in oscillator. So this will help you transform your sounds and do some filtering. So I hope you enjoy this episode. I'm sorry for the cheap selfie-like intro thing that we have going on here, but our new production assistant Inga ran out of the house tonight, and she's just like perusing the neighborhood, so we're kind of short-handed, so me and Crafty had to kind of do a cheap selfie video tonight. So anyways, I hope you enjoy the episode. Okay, hello. And we are starting traditionally at my website, just to show you LWMmusic.com. If you go direct to LWMmusic.com, you just click the face or the enter site logo here to get in. And then you'll get to the main page of the site. That was a slow load, but anyway, you go to the learning section, and that's where the Learning Synthesis with Pure Data series is. I also have Sunday night synthesis here. Incidentally, I'm recording on a Sunday night right now, so there won't be a Sunday night synthesis this week, but that might be something to check out anyway, if you haven't heard of it. But Learning Synthesis with Pure Data Series 2 is where we're at. This video will show up here right above Lesson 2. But Lesson 1 and 2 are here. If you haven't seen these lessons yet, you probably want to. The website is friendly to cell phones and mobile devices, so it's fine for you to browse there. But these downloads here are for PD, and you'll be probably doing that on a computer or tablet. But in any case, each video will have a lesson zip file and then an example zip file like these two here. And I'll show you that in a minute for lesson 3. But just in case, if you're at the YouTube channel, both series of Learning Synthesis with Pure Data, Series 1 and Series 2, are here in a continuing playlist. Starts with Lesson 1, Series 1, and if this is the first time you've seen any of these videos, you may want to start here. If you haven't seen any of the Series 2 videos yet, you will want to look at Lesson 1 and 2 before you go on to this one, because they show you how the system works that I'm using, called LWM Rack. If you click on the title of the playlist, it'll open up, and that's where you can find any video that you want. The last two here at this time are Series 2, Lesson 1 and 2. So you would start here to learn about LWM Rack, how it works, go to 2, and then proceed to this lesson. But those of you who are definitely sure that you're here for Lesson 3 because you've seen the others, then here we go. So the downloads are like so. As usual, there's an example and one that just says lesson3.zip. Lesson 3 is your blank patch file and your folder with the new abstractions in it, the new modules. And so if you have been following these lessons, you'll know that I'd like you to keep like a folder or zip file of your basic, unedited system on hand, so you can start from scratch and create your own saves in the folders as you go. So this will be the updated one. You can just delete lesson 1, lesson 2, and replace it with lesson 3 because it has the new modules added to it. And those would be down here: mono VCF module and mono VCF patch bay. But I'm going to show them to you in an example that I've already made. You can download this file and basically open the patch file. Oh, I'm sorry. It opened on my other screen, so I have to pull it over here. There we go. And let me pull over the PD window too in case I need to access it. So anyway, here's a working example already. And for the lesson, this is what's going to work out best for me right now in showing you basically how things work. This is the MIDI module in Patch Bay that you've seen in lesson 1. The VCO in Patch Bay from lesson 1 as well. Here's the new module, the VCF. It has an oscillator in it. You do not need to use the oscillator in it. It's just there for convenience if you want to oscillate your filtering. And we'll be hearing that in a moment. But here it is, and here's its patch bay. And on file, its file name is mono_VCF -module. And the other one is the same except -patch bay. If you've seen lesson 1 and 2, you know how I name file names. And so you'll understand that. And then the ADSR is up here. And then down here is our audio output. So basically what's happening is the MIDI is sending frequency to the VCO. The MIDI module is also sending gate out to the ADSRs, gate in. And you should know that from lesson 1. That's basically how you control your synthesizer. The velocity messages from MIDI are changed into a gate message that basically controls your ADSR over here. So it turns on and off with the ADSR envelope shape that you set according to these settings here. And then also, let me go into run mode here. And then also the VCO receives frequency data here. I have it hooked up directly, so the pitch bend wheel is being calculated in the frequency numbers that come out. And so that's how that works. Now that's kind of review there. But then the VCO has an audio out here that is going into the signal input of the VCF. So this is where the filtering gets applied to the audio signal. And then its audio output, of which it has 2, this left one is hooked up here. As you see, they are labeled LP and BP for low pass and bandpass filter. Basically, both outputs do come out simultaneously. In this case, I just have one hooked up because I'm just using this as a low pass filter. But you also do have a bandpass signal that will be coming out at the same time that you can also send somewhere or use that instead. We'll hear both in this overview in this lesson. And then here I have the audio signal going into the ADSR, and then the ADSR is going out to the left and right inputs of the stereo output module here, so we hear it on both sides. If my MIDI is set up right, it is, we can hear right now. There we go, everything's working. I have 3 more patches here. The mod wheel is going to 3 different things. And in fact, I am just going to use it momentarily so you can hear that. Aha! I have to turn off auto map on my keyboard again. It's not listening to the mod wheel. That thing keeps getting turned back on. So anyway, let's do this again. There we go. If you hear stuttering in the audio signals, because I'm recording the audio and video of this screen recording, and I'm recording a separate audio track from my voice with my headset. So there's a lot going on, so things may stutter. I'm doing that so that I can mix my voice levels with the output from PD. But in any case, what you heard there was a lot of stuff going on, because the VCF has in it, well, first of all, if you need a little bit of a review on what a filter is a filter basically takes the frequency spectrum of the signal you're sending into it, and it alters it. It usually is subtracting or carving things out depending on your settings. So let's hear this right now. So you hear a tone there. Since we're on low pass, there's this cutoff frequency right here, CF, that basically will cut off at a frequency relative to the note being played. And the reason why that happens is right here the frequency is going into the VCO, but it's also coming out of the VCO's patch bay going into here. This frequency input tells the VCF, okay, what note's being played. So for like a low pass filter, the lowest cutoff frequency is close to the fundamental pitch of the note. So you'll still hear a fundamental coming through. You still hear the note, but we're cutting off a lot of the harmonics. That's the cutoff frequency, right above the fundamental, cutting off all these harmonics. And it cuts it off in a slope, so you don't hear them all completely cut out, but you only hear a few in there that are, you know, the first, second, or maybe even the third overtone in there. And then as you turn this up, it lets more and more of the frequency spectrum through. And so you hear more of the harmonic overtones from this sawtooth wave, which is what's coming out of the VCO. Now, in addition to that, you have a Q setting here. This adjusts the cutoff frequency area and how wide of a Q it has, which is basically like, in the case of a low-pass filter, it's kind of like this bump or an area of resonance, as it's called, where that cutoff frequency stands out and kind of like sticks out above the other frequencies. For example, you can kind of hear where it is. You hear the buzzy area. The fundamental is, you know, it's a lower note, but there's a buzzy area up above it. And then as I adjust the Q, now you hear that stand out, and you hear the rest of the harmonics kind of go behind. And now I'm opening it up, so we're hearing more of the other harmonics come through. The Q varies depending on where you move it here, and what kind of filter you're using. For the low pass, if you move it too far down, it starts disappearing. You hear the sound disappear because the Q is getting too narrow, and it just cuts things out. So anyway, but you can adjust that for your timbre settings. There we go. Kind of sounds almost double reedy. Almost like a high register of a bassoon there. Just not as raucous. But anyway, next to it, this noise focus is like the noise focus on the VCO. This comes into play if you're using the noise oscillator on here. So now that you've seen how the cutoff frequency and the Q work, let's oscillate it. You don't have to do that. As you hear, you don't have to have an oscillator on your cutoff frequency, but if you want to, there is a rate slider over here for that, and an amplitude slider here for the amplitude of this waveform. There's also a checkbox here where you can say whether it has the DC offset in or not. If I well, let me just play it as is. I'm going to turn up the amplitude here, and then turn up the rate. It's oscillating in a triangle shape, the second selection. Top selection is a sine wave. But now you see, if I turn off this DC, it's oscillating between 0 and 1 now, whereas before it was going down to -1. Now what this does in most cases, it doesn't give you a cut in the sound that you get from the other way. But I let it so that you can select what you want, because maybe sometimes you do want things to cut in and out. For example, let me go to the square wave here. You hear that? Well, let's turn down there we go. Maybe you do want to cut, like right now it's pulsing. And let's turn on the DC. There you go, you get this rhythmic on-off. Speed it up. Slow down. Here we go. Okay, and then since we're on the square wave, we can also use the PWM here, the pulse width modulation. I'm going to turn off the DC so get a sound like that, and then use the pulse width modulation. See, towards this side, the pulses are longer, and the troughs are more narrow. And then if we go the other way, oh, I'm sorry. I think I'm speaking... No, I'm speaking correctly. There we go. Now the crests are more narrow. So you just hear that short little buzzy spike in there. And as you see, I get a little more room here with the Q. Okay, but in any case, you see there are a variety of settings. Oh, I didn't show the noise. Let me do that. There's also a noise oscillator here, so you can get that. Now, the cool thing about this, let me move the Q. Keep it right about there, but actually, if I put it on a square wave up here, it could sound a little bit like breath and stuff. So this is a way to get a little bit of breathy. A breathy sound in it. This would even be more effective if I had an ADSR on the output of this and a separate one for this. So that way I could actually have a different start and end time for the noise, the filtered section, and then the unfiltered version, and then combine them up later. Since this is an open modular system, you can do all sorts of routings. But anyway, let's go back to something that, at least to my ear, sounds a little more pleasant. Now, with the mod wheel, I have it controlling 3 different parameters here because you can actually patch one outlet to multiple inlets. But let's say, for example, we like that sound, but with the mod wheel, instead of controlling everything, we're just going to control maybe the rate of the oscillation. So over here, there's rate inlet. So now the mod wheel will control the rate. Maybe you want it to control also the amplitude of the oscillation at the same time. So there we can do that. Okay. But maybe, let's say for example, you didn't want to use any oscillator on this. Since I moved my mod wheel down, it's zeroed them out anyway. But you wanted to control the cutoff frequency with the mod wheel. Well, you could do that too. All these orange inlets and outlets take 0 to 1 values. Hold on, I need to move this so it's easier to get. There we go. So now, these orange inlets and outlets are all 0 to 1 ranges. So my mod wheel can go all these things. And last lesson, I showed you the a controller knob input. So you could run those controller knobs to all sorts of things. There's a lot of parameters on this. So anyway, now we're controlling cutoff frequency. Now you notice when I go all the way up, it kind of goes away. Well, when you have cases like that, that's why I'm going to be making a set of math modules that will allow you to, for example, take your 0 to 1 range here and then put a different min and max to it and adjust that as you need to for different devices you hook it up to. So those are all things that are coming. These different math modules will allow you to do a whole variety of things and adjust things so it's just right for the instrument or sound you're making. So anyway, as you see, a lot of possibilities there. Now I have a spring-loaded mod wheel, so it zeroes out all the time. But as you see, you don't need to hook this up. You can just kind of like say, all right, what kind of sound do I want? Let's go to a triangle wave up here. And then there you go. But you can adjust that on the fly. And of course, you can add other oscillators and other VCFs. You know, like since these are all named, you could have them named B or C or whatever and put together a much more complex instrument. I decided to just make something simple so you see how the modules work. But let's hear the bandpass filter here real quick. So I just disconnect this. I could connect up the bandpass filter. I mean, I don't have to set anything. It automatically emits anyway. It just, if you don't have it hooked up to anything, you won't hear it. So usually using one or the other, but you can have both come out and then combine them up in different ways. You know what? I may need to change my labeling. I think this is the low pass, and the other one's the bandpass. Because here, when I turn up the cutoff frequency, I don't hear the high frequencies disappear when it's all the way up. They disappear on the other one, probably because the band is too high above and you're not hearing anything. So the band that's being passed is too high. Here, if this being a low pass, this is passing everything below this point, so we're hearing a very full spectrum sound. And here's where things are getting cut out. There we go. Yeah, I think we need to change those labels. So anyway, I'll make that change before I put up the download. But yeah, these are the opposite. This is the band pass on this side and the low pass in the middle. So I'm going to have to change those. Let's hear it oscillate a bit. Yeah, that's usually a good thing to have on your mod wheel, so you can adjust that speed as you go more expressively. So anyway, that's the ins and outs of this module. Has its own patch base section, and as usual, let's go back here to the folder. And we're going to look into its folder, VCF, right here, mono VCF. We have an A being saved, and then there's a VCF-A. That must have gotten in there somehow, because I don't have, this was never named that. But anyway, I can delete that probably, because that's not being used. This is the save for this module. Here, for example, just moved something. Yeah, it's named properly. I don't know how the other one got there. But anyway, so check it out, try them out, have some fun. Let me know if you build something exciting, and I'll give you some attention for it, and we can collaborate a little bit. If you have questions or if you find bugs, please do drop a comment in the comment area below the video on YouTube. That way, if other people have questions and stuff, maybe they'll see yours and stuff. It's a good discussion area for this whole system. But for now, that's about it for this lesson. Next lesson, we're going to look at the VCMO, which is a modulation oscillator. So rather than carrying sound like this VCO, it's going to carry, it's designed for modulation, so you hook it up to things to modulate them. And so you'll be able to see that module next. And then as you see, the sky's the limit. As you get these different modules, you can mix and match them up in all sorts of different ways, and probably even in different ways that I haven't even thought of yet. So please do let me know about any of your inventions. But before we go, let me just point out one other thing. I have mentioned this in other videos before, but I am part of the Psyche Electroacoustic Opera Company. Here is the website. It's run by my wife, Liza Sahito, and it's a good place to check it out to see what we're doing. We're involving electronics, multimedia art, and everything in stage performances. You could see some of the preliminary videos, studio recorded videos and stuff here, and some other live performances we've done of some of the material. Our first full concert is going to be in August 26th. If you live in the South Florida area, please do check it out. But also, since some of you are interested in techie stuff, here she does on her channel, Psyche Electroacoustic Opera Company is the YouTube channel. You see here she does have some video tutorials on some things. This is a MIDI Dantiba that she made. This is a MIDI glove. And so there's all sorts of cool things here that you may want to check out. If you're on my channel on YouTube, let me go back to the main channel page here. Can we go back? Can we go back? Yes. Please. Hold on, I'm trying here. I'm working on it. Back buttons. There we go. You see, I do have it on the featured channels list here. She doesn't have the short URL yet for the channel, but also if you just search for Psyche Electroacoustic Opera, you'll know it by the eye. Incidentally, also, I should mention, as fundraising for this first concert, at the Psyche Opera webpage, you can go to the store here. If you are interested, we have some handmade, handcrafted zodiac eye necklaces right here. And so in this store, they are very reasonably priced, as you can see. And it helps raise funds for our opera company because we need to buy insurance for the first performance and pay our performers and everything. And so here you go. You actually do get a discount by being a viewer of LWM Music. In the checkout, you just type in LWM Music, all one word, LWM MUSIC, and you get 5% off your entire order. So if you order more than one, you get 5% off of all of it. So anyway, thank you for watching, and I'll see you next time for the modulation oscillator. Bye now. Inga, we were recording tonight. Where were you?